Okay, let's unpack this. Today, we're taking a deep dive into, well, a really crucial topic. It literally powers our world. The massive, rapid transformation happening right now in the energy industry. It's far more than just, wires and poles. It's kind of a hidden world. Incredible innovation, some really pressing challenges, and honestly, some truly surprising insights that affect your daily life.
Yeah, what's truly fascinating here, I think, is how intertwined everything has become. You've got the surging demands, often unseen, from things like AI data centers.
Right.
And then you have these groundbreaking advancements in how we actually design, build, and maintain the very infrastructure keeping our lights on.
So this deep dive should give you a vital shortcut to understanding, well, the cutting edge of power systems. We want to reveal the why behind the headlines you might be seeing.
Exactly.
We've pulled together really an amazing stack of sources for you. Everything from in-depth interviews with industry leaders, detailed reports from major conferences like Distributech, articles on the latest
There's
tech.
really good stuff in there.
Yeah. Our mission is basically to extract the most important nuggets of knowledge, the strategic takeaways, so you'll walk away, hopefully, incredibly well informed about where our energy landscape is heading. So, okay, let's start with the big picture then. Our energy grid, it's facing pressure like nothing we've seen before.
Unprecedented is the word, yeah.
We're talking about infrastructure that, in some cases, it's over 40 years old. It was designed for a completely different era.
And connecting that to the bigger picture, the demand for power is it's skyrocketing, absolutely skyrocketing.
So not just a small increase.
Oh, no. The Distributech report, for instance, highlights utilities seeing annual load growth rates jump from maybe historically 1 or 2%.
Which was predictable.
Predictable, manageable, up to as high as 8% in some areas.
Wow.
And this huge growth, it's largely driven by, power-hungry data centers, the massive expansion of EV charging, and big new manufacturing facilities coming online. Get this. One utility reported committing to serve 4.7 gigawatts of additional customer growth in just 10 years.
4.7 gigawatts.
By 2/3 of that, data centers.
That's staggering.
But here's the really stark figure. They have an uncommitted queue, requests they haven't promised yet, exceeding 15 gigawatts.
15
that they currently just don't have the resources for. So this points to a critical bottleneck, a really urgent need for massive investment, massive innovation, otherwise potential energy shortfall.
And what Mike Doolin from the Ori Detox series highlights about these AI data centers is truly eye-opening. Like you said, they're not abstract clouds. They are vast physical buildings that consume gigawatts of power, huge amounts of water, too.
Right. The physical footprint is immense.
And he warns about these unpredictable load swings. Jumping from maybe 10 megawatts up to 50 megawatts almost instantly.
Yep.
That really impacts local grids.
It's like plugging in a small city, then unplugging it randomly.
Exactly. It puts incredible strain on equipment that wasn't designed for that kind of volatility.
Which raises that critical question. What about the equipment itself, the stuff making up the grid?
Yeah.
Sean Shockey from ABB, he notes that a lot of the industry's electromechanical equipment is, frankly, antiquated.
Old tech.
Very old tech. Utilities are often dealing with, he calls it a mixed salad of equipment. Different manufacturers, different eras.
A mixed salad. I like that. Makes it hard to manage, I bet.
Makes standardization, maintenance, even finding compatible parts a huge challenge. And then layer on top of that, there's a significant workforce gap.
The people problem.
Experienced technicians, they're retiring faster than new ones can be trained up. And that just compounds the whole risk factor. You have old gear and fewer experts to look after it.
Okay, so given these immense pressures, these challenges, how is the industry actually responding? It sounds like it has to start right at the beginning with how things are designed and made.
It really does. It's shifting beyond just basic function. Alan Ross, in his editorial, he really underscores this point about reliability.
Okay.
For high-value, long life cycle assets, like, say, power transformers, reliability isn't just a nice-to-have feature, it's an absolute necessity.
Can't afford for those to fail.
Exactly. So reliability engineering now means embedding durability right from the conceptual design all the way through operation. They use tools like failure modes and effects analysis, FMEA.
FEA, right.
The idea is to anticipate and eliminate potential failure points before a component is even built.
So proactive, not reactive.
Precisely. The insight here, the paradigm shift, is we're moving away from just fixing failures after they happen.
Which is expensive.
And often disruptive
Right.
towards proactively engineering them out of existence from day one. Prevention is just infinitely more valuable than cure, especially now with our grid being so interconnected. And this includes, meticulously selecting materials like insulation that can handle the thermal and electrical stress for decades.
It's fascinating then to see how companies are trying to scale up to meet this need. Alberto Cracco from West Rotho, he shared their mission. It's rooted deeply in reliability, innovation, sustainability.
Core principles.
Yeah. And he emphasized, they've been building for the long haul for decades. This isn't just a new trend for them.
Right. It's in their DNA.
And their growth strategy seems really ambitious. It's global. A new production facility in Ohio, a seventh plant in Italy adding, 10,000 tons of magnetic core capacity per year?
Huge capacity increase.
And a second facility in Dubai. They're clearly betting big on this future demand.
Well, their investment strategy seems quite key, especially their focus on transformers using FR3 fluid.
FR3 fluid. What's special about that?
It's a natural ester fluid, and it allows for high-temperature designs. You can use thermally upgraded paper, high-temperature gaskets,
Okay.
which leads to transformers that are more compact, higher performance, crucially fire-safe.
Big safety factor.
It's more environmentally friendly than traditional mineral oil units. This is really critical for markets like renewable energy connections and those data centers we talked about.
Makes sense.
They actually expect those markets to grow at something like a compound aggregate rate of 12 to 14% in the next decade. So it's a strategic choice, really, for efficiency and safety.
And speaking of data centers, we touched on the immense power demands. But managing all that power, it generates a lot of heat.
A huge amount of heat.
Which leads us to some pretty cool innovations, literally, in how these places are cooled.
Yeah, indeed. David Sundin's article on immersion cooling really highlights this. It's a cutting-edge method. You literally submerge the electrical hardware.
Submerge it in liquid.
In a special non-conductive heat transfer fluid. It's a technique they actually borrowed from the power transformer industry, where oil serves as both coolant and insulator.
Okay, that makes sense.
And the effectiveness. It's astonishing. It's about 1,600 times more effective at transferring heat than just blowing air over components.
1,600 times.
Yeah. So it's surging in popularity for these really power-dense applications. AI, cryptocurrency mining, high-end graphics rendering. Anywhere you have a lot of heat in a small space.
And are there standards for this? It sounds kind of risky, submerging electronics.
That's a key point. The development of standards like UL 2417 is really important here. It specifically certifies the fire safety and material compatibility of these fluids. That's streamlining adoption and making sure it's done safely.
Okay, so we're making exciting progress on designing and building new cutting-edge stuff. But the reality is, a lot of our existing grid infrastructure, it's old. Decades old sometimes.
That's the challenge.
So how do we, breathe new life into these crucial long-standing assets, especially when getting new big transformers can take years right now?
Right. The lead times are a huge issue. And this raises that important question. How do we extend the life and optimize the performance of what's already out there? Well, the PTR Corner article on transformer services highlights something really interesting: refurbishment. It's become a highly viable, really attractive alternative to just buying new.
Refurbishment. So fixing up the old ones.
Essentially, yes. A properly refurbished transformer, it might cost only, say, 60 to 75% of a new one.
Okay, significant saving.
But critically, the lead time, you're looking at maybe 6 to 12 months.
Instead of
3 to 5 years, or sometimes even more, for brand new large power transformers right now.
Wow, that's not just cost saving. That's strategically vital. Bypassing those supply chain bottlenecks.
Exactly. It keeps critical grid assets online when waiting for new just isn't feasible.
So what actually makes a service business successful in doing this? It sounds complex. It's not just tightening a few bolts, presumably.
Oh, far from it. Success really hinges on several key pillars. First, you need a strong engineering-driven technical team. People who can actually diagnose complex problems and then implement the right solutions.
The expertise.
Absolutely. Second, you need the right tools and equipment. We're talking high-capacity oil pumps, vacuum units, specialized oil filtration plants, big cranes, high-voltage test gear. It's heavy-duty stuff.
Right.
Third, you need really strong operational management. These are complex projects. They need meticulous execution.
Logistics and planning.
And finally, targeted marketing. But not just glossy brochures, marketing that genuinely highlights the technical team's deep expertise and their proven ability to solve problems builds trust.
Okay, that makes sense. Now, delving a bit deeper, you often hear about certain components being maybe weaker links in the network, like low tap changers, LTCs.
Ah, yes, LTCs. They're definitely critical components, and because they're mechanical devices with moving parts,
They wear out.
they inherently wear out over time. They operate frequently to regulate voltage.
So how do you monitor those effectively?
Well, the article on DGA for LTC condition assessment really emphasizes dissolved gas analysis. It's arguably the most important oil test for diagnosing LTC problems.
DGA, analyzing gases dissolved in the insulating oil.
Exactly. As the insulating materials inside the LTC, the oil, the paper, the pressboard, as they deteriorate under stress, like heat or electrical arcsing, they generate specific byproduct gases.
Okay.
Things like methane, ethylene, acetylene. By analyzing the specific patterns and ratios of these gases, along with their absolute amounts, experts can assign diagnostic condition codes.
Like a health score.
Sort of, yeah. They range from 1, which means critical, needs immediate attention, down to 5, which is basically of no concern right now. This lets utilities prioritize maintenance effectively.
So it finds problems early.
It finds problems like localized overheating or excessive arcsing way before they lead to a catastrophic failure. There have been many documented saves using DGA. It transforms maintenance from guesswork into really precision diagnostics, extends asset life, averts costly outages.
So it's about the gases in the oil. Yeah. But is there anything else in the oil we need to worry about?
Oh, absolutely. Moisture.
Water in the oil.
Precisely. The presence of moisture is kind of a silent but very serious threat. It compromises both the insulating oil itself and the solid paper insulation wrapped around the windings.
How does it get in there? Leaks.
Sometimes leaks, yes. But the Control and Prevent Moisture Presence article highlights something else. Moisture can actually originate internally as the paper insulation ages. It's a chemical byproduct of cellulose degradation.
Ah, so it can generate its own problems over time.
It can. And while traditional oil sampling, taking a vial now and then, gives you snapshots.
A moment in time.
Exactly. It doesn't show you the dynamics. So continuous monitoring technologies are becoming much more common. Things like self-dehydrating breathers that actively remove moisture from the air entering the transformer, and advanced online oil diagnostic devices.
Like the ESDB or EDOC mentioned.
Yes, like those.
Yeah.
They continuously measure properties like moisture content, dissolved gases, right there on the transformer in real time.
You see trends, not just single points.
Precisely. It enables truly predictive maintenance. You can intervene before a problem escalates based on actual data trends and significantly extend the transformer's life.
Okay, so we diagnose it, we maintain it. And once the transformer is installed, or maybe after it's been serviced, how do we actually know it's performing efficiently
Yeah.
out there in the field? We kind of just assume the factory tests were right, don't we?
That's historically been a bit of a blind spot. You're right. Factory tests are essential. Absolutely. But they're done under controlled conditions. They don't account for potential bumps during transport or the specific conditions of real-world operation, different temperatures, load cycles.
Right, reality is messy.
It is. So Megger's multifunction TAU3 test set, which is highlighted in that article on field-based transformer efficiency testing, is quite a step forward. It allows field teams to accurately measure the total transformer losses.
Both types of losses. No load and load losses.
Yes, both the no-load losses, which are always present when it's energized, and the load losses, which depend on the current flowing through it. And they can do this right on site with just a one-time connection. It integrates pretty seamlessly into existing testing workflows.
Why is it so important, measuring efficiency in the field?
It's vital for several reasons. First, verifying the manufacturer's supplier claims. Did you get what you paid for? Second, it supports more precise condition assessments. Efficiency changes can indicate internal problems. Third, it helps make informed replacement plans. Is this old unit costing us too much in lost energy? And finally, crucially nowadays, for carbon reporting, meeting ESG targets. Losses are wasted energy, which means unnecessary carbon emissions. Especially important for the literally tens of thousands of distribution transformers out there, which are often the least monitored part of the network.
Okay, so we've explored how these diagnostics help us understand the health of individual assets piece by piece. But what happens when we zoom out? When we start harnessing all that data across the entire grid, this is where digital transformation, especially powered by AI, seems to be fundamentally reshaping things.
Absolutely. It's moving from individual components to system-wide intelligence. And power quality, or PQ monitoring, is a big piece of that puzzle now.
PQ, making sure the electricity is clean.
Essentially, yes. PowerSide's view really highlights that high-fidelity Class A PQ monitors these adhere to really rigorous standards like IEC 61430 Edition 3.
Which sets the bar for accuracy.
Sets the highest bar for measurement accuracy, synchronization, aggregation methods. They provide far more detailed, reliable information than, say, a standard smart meter.
What kind of detail?
They can precisely capture and analyze disturbances like voltage sags, swells, interruptions, harmonics, things that can wreak havoc on sensitive equipment. This detailed data allows utilities to proactively identify the sources of these disturbances and mitigate them. It significantly improves overall grid stability and helps prevent costly outages or equipment damage for customers.
Okay, so we're getting much better data. Now,
Yeah.
where does AI fit in? We hear so much about it. Is it going to take over everything, or is it more like a sophisticated assistant for the grid?
That's a great way to put it, a sophisticated assistant. The DTEC report and Christy McDermott's article on AI's role in utility asset management, they really clarify this. AI is moving beyond just being a buzzword. We're seeing truly practical applications now.
Like what?
Well, automated systems, for example, like those from Sharper Shape. They use advanced machine learning algorithms to analyze imagery, maybe from drones or helicopters scanning utility poles and other assets.
Looking for problems.
Exactly. They can accurately identify defects like cracks in a pole, corrosion on hardware, vegetation encroachment, things that a human inspector might miss or that take a long time to find manually. It streamlines inspections, makes them safer for personnel, and drastically reduces human error. So it's augmenting the human workforce, making them more efficient.
I love that phrase that came up, retiring the measuring tape. That really captures this shift, doesn't it?
It really does. It's a powerful analogy for a fundamental change in how work gets done. Look, AI's CAM system, which was highlighted at Distributech, is a perfect example.
How does that work?
It uses advanced camera-based data capture, like photogrammetry, combined with powerful AI processing. It creates highly accurate survey-grade 3D models, digital twins of infrastructure, like substations or power lines.
So a virtual copy of the real thing.
A very precise virtual copy. This allows field teams and engineers to do things like virtually place new equipment, accurately measure clearances between conductors, model complex upgrades, all from their desktop.
Before even going out to the site.
Exactly. It shifts utilities away from just reacting to problems or doing manual surveys towards incredibly precise, proactive resilience planning. Imagine redesigning a whole section of the grid, checking every clearance, planning every step virtually before the first crew even arrives on site. Huge efficiency gains.
Integrating this kind of advanced AI, these digital twin systems, into utility operations, which often rely on systems that are, well, decades old.
Yeah.
That must have significant challenges, right? It can't be as simple as just plugging it in.
Oh, you're absolutely right. It's far from straightforward. Integrating advanced AI into existing, often quite outdated, utility IT and OT systems, it usually requires extensive customization and significant training for the workforce to use these new tools effectively.
And the data itself.
That's the other big hurdle. High-quality, structured data is essential for AI to work well. Utilities often have vast amounts of data, but it might be unstructured, inconsistent, stored in different silos. It needs rigorous cleaning, organizing, labeling before AI can really deliver on its promise.
So it's a big upfront effort.
It is. But the potential long-term benefits, the cost savings, the vastly improved asset management, the enhanced grid reliability, they generally justify the investment. We're seeing many utilities wisely opting for phased implementations. Start small, prove the value, then scale up.
So it's really interesting. Despite all this incredible technology, the drones, the AI, the advanced diagnostics, it really sounds like the human element is still absolutely crucial.
It is, perhaps even more so now in a different way. Sean Shockey emphasized this point too. While AI is going to be, as he put it, super essential for sifting through these massive amounts of data, flagging anomalies, finding that needle in the haystack, humans are still required to make the critical judgments, interpret the context, and, as he quite bluntly said, save us. AI directs the attention, it points the human experts to the right places, allowing them to be far more effective, more strategic with their valuable time and deep expertise. It's a collaboration.
And speaking of collaboration, is that happening more broadly between different players in the industry?
Yes, definitely. We're seeing unprecedented levels of collaboration now. Utilities, technology vendors, research labs, regulators, they're increasingly working together to tackle these huge systemic challenges. Things like the workforce gaps we mentioned, supply chain bottlenecks for critical equipment. No single entity can solve these alone. It requires a collective effort.
It certainly sounds like a complex time, maybe a challenging time, but also an incredibly dynamic and exciting time to be involved in power systems.
Couldn't agree more. The pace of change is just phenomenal right now.
Well, we have covered a tremendous amount today. Really fascinating stuff. From those intense physical demands of AI data centers and the surprising innovations in cooling them,
The immersion cooling.
to the incredible advancements in how transformers are manufactured for reliability, how they're maintained strategically through refurbishment.
And the diagnostics that enable that.
Right. And finally, how AI is rapidly transforming asset management right across the grid, moving us towards that more intelligent system.
And hopefully you've gained a deeper understanding of the critical elements that are needed to build a more resilient, more reliable grid for the future. Things like that concept of reliability by design, the strategic shift towards transformer refurbishment to manage assets and lead times, and the real power of sophisticated diagnostic tools like DGA and those new field-based efficiency tests.
It's crystal clear that the energy sector is undergoing this profound and frankly necessary transformation. It's driven by both immense pressure and incredible innovation working together.
Absolutely.
So as you, our listener, think about how all these interconnected pieces fit together. Here's a final thought. What might be the next silent threat, maybe lurking undetected like moisture once was? Or perhaps what's the next unforeseen benefit that we're only just beginning to grasp as our energy grid becomes even more intelligent, more responsive, and truly interconnected? Something to ponder.